free radical can be of two types. First one, type of CH3 type of, or CD3 type of, or CR3, R means alkyl group. This type of free radical are one kind of free radical. Second type of free radicals are like CX3 type of, CF3, CCl3, CBr3. These are another kind of free radical. This kind of free radical, these are planar. Carbon H, one above the plane, H, H. These systems are planar. This is planar. And tell me, what is the hybridization when a system is planar? Yes, this is sp2. This is one electron, that extra electron is there. So this is sp2 hybridization. Bond angle 120 degree. Is it so? It's a homework for you. Search what is bond angle for CH3 free radical. Homework. Okay. Now, so CH3 dot, this system is planar. But this kind of system, CF3, let's see what is the problem in planar structure for this kind of system. CF, F, like this, F. Now, fluorine is very much electronegative than carbon, then there will be very much negative pole. There will be very much negative pole, delta negative, delta negative, delta negative, delta negative. Now this lone pair, this single electron will undergo very much repulsion with this negative charge. All these three are actually equidistant, isn't it? This lone pair, this p orbital, and this bond is basically 90 degree distance. So all are in equal distance. So all will be facing similar kind of repulsion with that single electron. So what will happen? This bond will shift to lower side. So the resultant structure should be C, like this, F, 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 F. So this is basically tetrahedral. The structure is tetrahedral and hybridization is sp3. Here sp2, planar, it is tetrahedral sp3. So this will be similar kind of CCl3 dot or CBr3 dot, all will be same, right? But there are different explanation also. There can be three explanation why CF3 is tetrahedral but CH3 is planar. So CH3 dot, that is planar, versus CF3 dot, that is tetrahedral. It can be explained in three ways. Different authors explain in a different way. First one, it can be explained through VS-EPR theory. We know when terminal atom is more electronegative, then bond angle is less. Terminal atom has high electronegativity, then bond angle is less. If you have read anywhere VS-EPR theory, then the conditions, the statements written there, you can correlate. That's why here bond angle is lower. Actually, the bond angle is 112 degree, but obviously this is lower. This is not a kind of sp2 hybridization. It is more or less a kind of similar. It is nearly equal to sp3 hybridization bond angle. Now, this is one explanation, VSEPR theory. Second is %S character or hybridization. If the structure is planar, then S character S character is 33%. If it is sp2 hybridization, if this structure is sp2, then S character is 33%, because it is sp2 kind of planar structure. But if it is in tetrahedral form, then S character will be 25% or sp3, isn't it? Now, S character 33% means more electronegative orbital. That means orbitals will be more electronegative, and thereby it will face more repulsion. More S character means more electronegative orbital. That means more repulsion. That means this orbital and this orbital electrons will show more repulsion. But here S character is less, so repulsion is less. These are two explanations, and another author is explaining this thing is in like there occurs some is saying that there is hyperconjugation like phenomenon. Hyperconjugation like phenomenon that occurs here, and you have no need to understand this in depth. So just understand these two explanations very well and just take it as a knowledge that there are another explanation also that is saying that it is hyperconjugation like phenomenon. Okay, hyperconjugation like phenomenon between whom? Between fluorine lone pair and sigma star of CF bond. So these are basically uh, these are basically the structure and bonding part of free radical. Uh, Two homework for you. Find the stability order. First one I am writing CF3 dot is less stable than CH3 dot. Just search in Google or search in anywhere, ask your teacher, ask your friend. So what is the reason behind the stability order? It is homework for you to research about it. Why this order is like that. Then CF3 dot will be less stable than CH2F dot, then CHF2. This is the stability order. This stability order is correctly written. Just what you have to analyze or what you have to self-study, that why is it so. So do that yourself. Till now, have a nice day.